5. 2.5 talks about something that we already know, okay, but we know it by another name, okay? Average rate of change. Anybody know what average rate of change is? It is slope. Good, okay? So we already know this, okay? And if we have time, we'll revisit a little bit of the increasing, decreasing functions again. We'll just see where the time takes us. But slope and rate of change. Slope and rate of change. We are going to approach them the exact same way, okay? They're very, it's an extremely analogous statement when we're talking about linear functions, okay? You guys know average rate of change, okay? Maybe you've seen these formulas, change in input divided by change in output, okay? Those of you that are in physics, you see delta Y or delta X. You agree with that? Okay. Algebra 1, we've seen it as Y2 minus Y1 over X2 minus X1, okay? That is exactly the same as change in output over change in input, right? That's exactly the same as delta Y over delta X, okay? Delta means change, right? And if we look at that bottom one, now that bottom one's more in function notation, but it's taking a Y value minus another Y value up top, okay? And then dividing by the difference in the X's that produce those particular Y's, okay? We've actually seen recently another version of this. If you guys remember, we dealt with f of a plus h minus f of a all over h, right? We dealt with, we call that the difference quotient, okay? However, if we think about what that one is saying, just kind of making some comparisons here, okay? The f of a plus h, so well, let's actually look at this one first. We understand that one, I think, a little bit better. It's saying you have an x sub 2 and you have an x sub 1, okay? And maybe your graph is doing something like that, but this would be f of x sub 2, and this would be f of x sub 1, right? That's what those y values are, okay? So we take this y value minus that y value, and then divide it by the x value that created this y value minus the x value that created that y value, right? That's what this formula right here is saying. Well, this is just a redefinition of variables. Instead of calling this x1, this difference quotient calls this a. Okay? And instead of calling this anything specific, they say that that distance right there is h. Well, if we go back to geometry and go through the segment addition postulate, so I start at 0, 0, and I go to there, I've walked a units, right? And if I keep walking, I've walked h more units, right? So in total, I've walked a plus h units. Does that make sense, everybody? So that x value is a plus h. This x value is a. Well, when I plug those in, now it's not f of x2, it's f of a plus h. It's not f of x1, it's f of a. Does that make sense? And then I do the difference in those y values. Now, if I do the difference in these x values then, if this is x2 and this is x1, and I subtract them a plus h minus a, it leaves me with just h. So what I want you to see there is that those two formulas are identical. They're just a redefinition of terms or variables, okay? But we've been working a little bit with, I gave a couple different demonstrations with that difference quotient and how we find slopes on particular curves. That's analogous to finding slopes on lines. Okay, it's the same thing. We see a little phrase down here at the bottom. You don't need to write this down, but it says if f of x equals x plus b, so if it's linear, average rate of change is slope. Okay. Now here it's just a vocabulary thing that we do. This is the average rate of change for a linear function is constant or the same all the time, right? We know that. That's kind of the first thing that you learned in Algebra 1 when you dealt with slope. It's always the same between any 2 points you choose, okay? So because of that, we usually don't call it the average rate of change for a line. We just call it rate of change. So I want to make sure that we understand that as we're going through problems in the homework, some of them will say, find the rate of change. Others are going to say, find the average rate of change. Well, usually when they say average rate of change, they're probably implying that your graph has some fluctuation and is not necessarily linear, okay? But you can still average it out and see what the average rate of change is, okay? All right, so this is an example. You don't have to write this down. I just want to walk through it. It's something that you learned in Algebra 1 again. It says a dam is built on a river to create a reservoir, okay? So the water level, F of T, in the reservoir at time T is given by that following function. F of T equals 4.5 T plus 28. It says where T is the number of years since the dam was constructed and F of T is measured in feet, okay? The plus 28, graphically, the plus 28 is the what? Y-intercept, okay? 4.5 T is my slope, right? Well, 4.5 is telling me how many feet this thing is rising every time T increases to the next year. Does that make sense? Okay, so that is my rate of change of the water table in this reservoir. Does that make sense? So what does a 28 mean to me kind of in this situation, physically in this situation? The 28 would be what? Okay, so that would be the water level would have started at 20 before I made the dam, or the instant I made the dam. The water level in the reservoir is 28 feet tall, right? Okay, and then it's changing at 4.5 feet per year. So what they'll ask you is, well, what's the slope? Well, you guys know it's 4.5. Okay, and the next question says, well, what's the rate? The water level in the reservoir is changing. Well, if we read that and look at that, and look at that, they're asking what's the rate of change? Well, we know the rate of change is the slope, 4.5, right? Okay, so those are hopefully maybe simple linear equations that we can recognize that information from and just pull it off of the function. Okay. All right, so I want to look at the way I had this in the PowerPoint and where I found this problem. It just kind of sucks because it's much bigger than the screen. But reading that to you, I know it's far away. It says gasoline costs have experienced some wild fluctuations over the last several decades. Okay, it says this table lists the average cost in dollars of gasoline for the years 2005 to 2012. Okay, and then eventually it asks us at the bottom there, it says using the table, find the average rate of change of the price of gasoline between 2007 and 2009. Okay, what I want us to investigate first is this a linear function? Is this a linear function? Is the average, or not the average, the common difference between those two values the same as between every other two sets of consecutive values? So if I subtract those, I get, what, 31 cents? Okay, and it'd be positive, right? If I look at the next two, that one and that one, what's that give me? Yeah, 22 cents. When I look at that one and that one, that's positive 46. Okay, when I look at this one and this one, now it's negative, right? Okay, what's that? 30, and then 59, so 89 cents. Okay, so we're seeing that the fluctuations, graphically this thing is, it's a line graph, right? Okay, you guys have dealt with line graphs and histograms and that kind of stuff before, but this is a line graph, and it's going to show ups and downs. Okay, but what we can still do is determine what the average rate of change is between 2 years, any 2 years. So when we look at these data points, guys, this is the way these data points are provided. The Y is your input. The C of Y is your output. So all of our ordered pairs here are going to be a Y, comma, C of Y. Now, when I say Y here, it's not a Y value. Does that make sense? They're using that letter to represent year. Okay? So maybe to eliminate a little confusion, it might be better to say T, comma, C of T for time. I think that's probably more appropriate, so you're not crossing concepts with your variables here. But all of these, so it would be 2005, comma, 2.31. It'd be 2006, comma, 2.62. Does this make sense? 2007, comma, 2.84. Now, I don't like doing that. I don't like writing the ordered pairs like that because 2005 and 2006, 2007, that gets a lot to write. It gets messy. I don't want to do the math with those things. So what I usually do, and this is perfectly fine, hopefully you've learned this in the past, isn't this my first year or my initial year? So why don't I just say 0, comma, 2.31? And this one be 1, comma, 2.62. And this one be 2, comma, 2.84. If I look at this one, so this is, would you agree that there's still, if I subtract those, it's the same thing as if I subtract those two? So there's still a difference of 2 years in those ordered pairs. Does that make sense to everybody? You guys, have you seen that before, that you can do that? Okay. I think that's very useful in a lot of questions that they ask you to use an input value that is a year, okay? Just let your first one be 0. And, I mean, you can even let the first one be 1 if you wanted to. It doesn't matter. You can start anywhere you want. It does not matter, okay? But I would make the correlation at some point, hey, remember that 0 was year 2005. So then when I get maybe 5 back, okay, when I do the difference in years, I get a 5 back. Well, I know that's really talking about 2010. Does that make sense? Okay. So just be cautious of that. But wants to find the average rate of change between 2007 and 2009. 2007, so that one there, and 2009. Okay. Well, our formula says average rate of change is equal to the change in your y values divided by the change in your x values, or the change in your output divided by the change in your input. So now what they're saying is gasoline price is dependent on the year. Does that make sense? That's when it says that gas is a function of the year. Okay, that means gasoline prices are the output. Okay, so if I take 2.41 and subtract them at 2.84, and then divide by however you want to do this. You want to call this 2007, 2009, or if you want to call it, well, we have 1, 0, 1, 2, 3, 4. If you want to go 4 minus 2, does not matter. Just be deliberate, right? 2009 minus 2007. When I do that, okay, the top gives you negative, 43? The bottom gives you 2. So it becomes negative 0.215. Does that make sense, everybody? So what it's saying is, even though between 2007 to 2008, we saw an increase in price, correct? We saw a 46-cent increase. And then from 3 to 4, we saw, or 2008 to 2009, we saw an 89-cent decrease. Well, that means we went up and we also went down, right? Okay, so at those specific data points, we don't experience a negative 2.15, or sorry, negative 0.215, but overall, averaged out along those 2 years, we experienced a 21.5-cent decrease per year. Does that make sense? Okay. If I started at, let's say we started at 284, 2.84, and if we subtract from it our 21.5 cents one time, okay, and then subtract from it, so that would be maybe year 1, and then subtract it from it again a second time, okay, 2.84 minus this thing 2 times because we're looking at a gap of 2 years. Does that get me to 2.41? Does that make sense? And that's the idea of average rate of change, is telling you how much did you change per year on average. Okay? So that's what we're looking for in questions like that. Does that make sense? Okay, they ask then similar questions. This is more of a graphical approach or a graphical type question, but it's the same thing. They are giving you 2 ordered pairs somehow. We just have to realize how they're giving them to me. Negative 1 to 2. That's the average rate of change interval that I'm interested in. So I'm going to be looking at figuring out what is the average rate of change of this graph in that pink region. Does that make sense? Okay. So what I need to be able to do is understand what is the input. Well, the input are these values. The output would be the ordered pair's y value. Okay, so -1 is the input, 4 is your output, right? Does that make sense? Okay. +2 is your input, 1 is your output. Okay, so here we've got the ordered pair -1, 4. Here we've got the ordered pair 2, 1. If I want to find the average rate of change, it's the change in y's over the change in x's. Can I go 4 minus 1 over -1 minus 2? So you get 3 over -3, which ends up being -1, right? Well, think about what we just did. We just actually found the slope of that line right there that connects those 2 points, didn't we? Oh, look at that line. Is that down 1, over 1? Okay. And here's the idea. That's the average. You know, if I go over a span of 3, okay, here's the idea. I start at a height of 4, and it's saying if I want to go on the x-axis, if I want to go over here 3 units, okay, then my average rate of decline, okay, across those 3 x values to get to that point right there, my average decline has to be 1 unit. Okay. If you think about this, this is something that we talked about in the last class. If I look at just that, okay, that's over a difference of 1 in the x distance, right, or x direction. So my denominator would be 1 here. There's an average rate of change of 4 down to 1. That's an average rate of change of 3 there, right? Does that make sense? Okay. Well, if I look at another interval right here, that's the same interval in the x direction. It's still an interval of 1. So my denominator is still 1. There my average rate of change is what? -1, right? Does that make sense? Okay. I went in the blue, I went down 3. Here I went down only 1 in that interval. And then if I look at this one here, what's my average rate of change there for if my denominator is 1 again? That's an increase of 1, isn't it? So in those individual intervals, we're seeing different rates of change. Does that make sense? If I collectively look at them in that pink, okay, the average rate of change, well, we went down 3, and then down 1, and then up 1. Well, that's a total of -3, right? Down 3. Okay. And what's the average distance? So what's the total distance I want to cross the x-axis? It would have been 3, right? So if I average that out, I get -3 over 3, which is -1. Does that make sense, everybody? Okay. So that's one way that they're going to present to you a question about average rate of change. And so they're hiding kind of ordered pairs here, right? The slope question is hiding ordered pairs. Next one I want to do is something like this. Okay, this will be the last one we do. To find the average rate of change of this parabola on the interval 5 to a. Okay? If I look at this parabola, I'm not 100% confident on the structure of this. I know it's concave up, it's +1. I know it's got a y-intercept of -8. So let's do that. I'm not sure how far down it goes. But let's say that this thing here, so let's say that's my x value of 5. They're saying, so remember our intervals have to be chronological, right? So 5, and then this is going to be a here. So ultimately, what they want us to figure out is when this thing, what is the y value when that thing is at 5? So we're going to find f of 5 here in a little bit. And then obviously my graph kind of runs out here. But up here eventually, there's going to be an f value of a, isn't there? Does that make sense? They want us to subtract this. So we got to find these two things. We got to find f of a, and we've got to find f of 5. We've been working a little bit on that, right? Taking an input of 5 and plugging it in. If I plug 5 in, it gives me 25 plus 10 minus 8, which is 27, right? There's f of 5. F of a is a squared plus 2a minus 8, right? Does that make sense? Okay. Well, what are these? These are just y values, correct? Maybe I want to call that y1 and that y2. Then that would have been x1 and that would have been x2. Does that make sense? So if I want to do delta y over delta x, okay, sorry, this would have been a 2 here. I'm going to go change in y's. So I'm going to go 27 minus a squared plus 2a minus 8 all over, okay, now change in x's would be 5 minus a, right? Does that make sense, everybody? Okay. Now, you could have also done the flip, because the formula doesn't know what I let x1, y1, and x2, y2 be. So you could have also done this as change in y over change in x is equal to, you can go a squared plus 2a minus 8, let this be y2, and let this be y1, so you get minus 27, and this would be a minus 5. I think most people are going to like it this way, because just kind of watch this. I got a squared plus 2a becomes negative 35, doesn't it? Over a minus 5. What's that factor to up top? A plus 7, a minus 5, a minus 5 on the bottom. They give me a plus 7 as my answer. Okay, so that's the average rate of change. If you know what this is saying is, if I had this parabola and I want to find the average rate of change between 5 and a, all I got to do is take a and add 7 to it, and it gives that to me. Okay, so if a was 3, the average rate of change between 5 and 10, does that make sense? Or sorry, 5, let's say a would be not 3, it can't be 3, it's got to be to the right. So let's say a is 10. Okay, all I got to do is take a plus 7, so I get 17. That would be the average rate of change between the x value of 5 and the x value of 10. Does that make sense? It allows me, that formula allows me to find the average rate of change much faster than going through this entire process several times. And the idea of having that is so that a value can move left and right, and I can evaluate it at several different points very quickly. If I want a to be 6 and a to be 7, a to be 8, a to be 9, I can just plug in that a plus 7. It's going to give me the average rate of change for each of those specific instances. Okay? If I look at that top one here that we did, and then we'll stop, the same thing happens. So this would be 27 minus a squared minus 2a plus 8, right? Over 5 minus a. Well, I would rewrite that as maybe negative a squared minus 2a plus 35 all over. Now I'm going to take this, and can I rewrite this as negative a plus 5 on the bottom? All right, now a lot of people are going to maybe struggle factoring this, but think about this. Negative a squared minus 2a plus 35. Can I rewrite the bottom as this? Can I factor a negative out? That make sense? And when I factor that negative out, can I actually take that negative and put it up top and distribute that to the top? A squared plus 2a minus 35 over a minus 5. Is that the same thing? Is that what we had over here? Okay. I just think if we see 5 minus a, a lot of people struggle in recognizing that that is actually the opposite of a minus 5. And we'll struggle seeing what cancels when we factor. We'll stop there, but hopefully that is enough information for some of the questions that are going to pop up in some homeworks about average rate of change. It's simply slope.